those customers. They're the ones that are getting slowed down. Why? We start looking into more and more things. It tells you how many events have been stitched together. That's a really, really basic example. But where it really starts turning into being powerful, that's just looking at one ID and saying, stitch all those together. But what if you want to say, I need to use parts of the data to determine if this is a transaction? It starts with this, and also it can't go longer than 10 minutes. Or I only want to get things that are, I know there should only be a certain amount of events in that transaction. So they're in that transaction. So there's all these arguments that allow you to really look for specific stuff in your data and look for really, really specific things that are happening. So here I'm saying, look for JSession ID and client IP across all that data, put those together. I want to look for where the client added something to their cart and then ended with a purchase. Show me everything in between, but it shouldn't be longer than 10 minutes. That way it just doesn't, what if they made multiple transactions during the day? I don't want to make one big 24-hour, it took them this long. Well, what if they bought things multiple times? There's all these different ways you may want to kind of shape shift and ask different questions. And so that's what that command will do, link things together.
So how this transaction differs with a join?
It looks for those, there's different ways. Oh, he asked how does transaction do the join?
No, how the transaction is differing from the join.
Oh, how does it differ? So there's one, when I was back there, I did have something that says, hey, you can use stats to do this too, and just kind of split fields, and it does an implicit join on time. Transaction gives you more ability to look for this string in here, and then end it with, that transaction will only end if I find this string. Use time as a boundary. It gives you ways to do more than just a single join between this, this piece. It says, I want to join things on time and keys and time ranges. It's essentially letting you take multiple different ways to make a join. More complex ways of saying, I need to stitch things together. And then you can run, stats on top of all that. Say, what is the overall average of all my stitched together transactions? So it just gets again, I'll be happy to talk with you afterwards too. Like I said, transaction's a tough one to explain, but super powerful. So just, let's see, we've got about 13 minutes left, so I want to go over a few more things. So these I call exploration commands. There's 30 more of these things. There's tons of these commands. And what's nice with Splunk, you get used to SPL and you start using it, you find out, wait a minute, there's all this stuff I can do where I don't even know what question to ask yet. Like, where do I start? I just want to explore what's in this data. So we have things like cluster, and that's just clustering events together, saying, right now I've got, let's see if I run this by itself. Again, in this example data set, I've got something like 120,000 events. Well, what can they be classified into? And so it's got it down to 8 results, and then I can sort and see, well, what are the most common and what are the most rare type of events I have in here. Now this is just one data set, so maybe I should add in, I don't think I have much more in here. We have some internal data that Splunk logs itself, so I can throw that in there. And now I can see that I'm, again, clustering, finding the most common type of log event I have versus the most rare. And sometimes that's really nice to find something in your entire environment that might be going wrong and you had no idea where to even start to look, right? Just a random log file in there that, okay, interesting. Some funky errors in here I might have not known before. There's also field summary. So let's say you get a whole new data set in there and you want to know, well, what are all the fields available to me in that data set? And what are just some simple things like the mean, the max, the min, the standard deviation? What are some example values in there? So this is just telling me, hey, in this index, in this data that I've got, here's all the fields and here's some information about it. So this gives you a starting point to, if you need to classify it a little bit. And correlate. This says, well, of those fields, how often does the action field exist when there's a JSession ID in that event. So apparently 35% of the time. Well, that helps when you're working with dirty data, right? Just you're wondering, for every single event I have, and you think of every, is there a value for every column? If you're working in like Excel terms, we call them fields. Is there a one-to-one relationship for things existing? So now you know, well, oh, we must have some nulls. Whenever there's a client IP, unfortunately, we only have a JSession ID 50% of the time. That's interesting. Maybe I need to go, where I'm collecting my data from, maybe we're not logging right because we want to make sure we have a JSession ID every time. Helps you go back and clean your data, so it's good to explore. Contingency is the same thing, but from a value perspective. This said, how many times does this field exist when this field exists? Contingency says, how many times does this value exist in every field versus this value from? Well, I picked two, so I picked URL and status, and it said, here's every value on one, here's every value on the other. Give me a table of how often that value exists with this value. Again, it kind of comes up with some interesting patterns. And then the last one, actually there's 30 more of these commands, but I just picked a few of them. Analyze fields is give me a field such as status, and then show me what other fields in that data set might help predict that value of status. So for example, in this case, it's saying, so in status, let me explain that field. It's your 404 or 500 or 200 or status code. So it's saying, hey, if it's a 200, what other fields could I use that help me predict that it's going to be a 200? And so what you'll see is when you get to the machine learning session, if you're going there, all these SPL commands can help you figure out what are the most important fields, and they call them features in machine learning, that are going to build the best models for you. And so, because right, if you've got millions of things to pick from, how do you say, how do I build the best model for this data set? So all these SPL commands can actually help you kind of pinpoint what are some of the most important fields. What helps predict this field the best? Here it's saying bytes is with 10% accuracy. If I know what bytes is, I can predict if it's going to be a 200, a 400, so on. So just fun. I say fun just because I probably make it fun for me. I just like exploring around. But how do I determine if I don't know anything about this data set? How do I not be scared? Like the more advanced people get with Splunk, the less scared they are to just start throwing everything in. They're like, just throw it in Splunk because I'll figure it out. I'll be able to classify. I'll figure out what's important with it, and so on. So let's talk about custom commands, and then I want to leave at least like 5 or 6 minutes for questions here. So sometimes you may have a command that doesn't exist in Splunk yet, or in our language. You need to do something extra. For example, I once needed to, on the fly, was in a sales thing, and I needed to be able, someone asked me, I need to calculate the distance between these planes in the air, all real time, and calculate the distance between 2 GPS points. I'm like, well, we could get the algorithm and go plug that into SPL using eval commands and the like, but maybe there's a command that someone's already built to do just that. So haversign happens to be a calculate the distance between 2 GPS points. I just went on Splunk base and I typed distance, and a haversign popped up. So I downloaded it, installed it, and it's just like any other Splunk command now. And it takes in arguments, and just a lat long. And so here I just said run IP location to get all the cities and lat longs. I just searched for cities starting with A just to limit the data set. And I said, give me the distance between all those points from this lat long, which maybe is Denver, I don't know, since that's where I live. So it gave me the distance. And now you could run whatever other stats on collision avoidance or whatever use case you might be using. But again, something that didn't exist in SPL, you can put it in yourself. I think right now they're all Python. Levenstein, this was a fuzzy string algorithm, so compare how like 2 strings are. Just wasn't something we had in the original language. But you can extend it, nice and easy. All right, so let's pop over back to this quick and finish up and ask some questions. You guys will learn a little bit more about ML. There's some resources. They'll send this presentation out, and you'll be able to get some of these links. Again, the app, you can download that app, and it's got that example data set in there, and go reverse engineer some on your own. And then we've got you heard these workshops coming up. I think we are building a Power of SPL workshop where now it'll be hands-on. You guys will follow along. We'll get much more in depth with building those custom visualizations yourself, doing some machine learning with those commands, and really using that app and tweaking SPL. So highly recommend those workshops. Conf, you guys have heard about this. And then we've got our pony poll, definitely go on there. And I hope that gives you guys a good little intro into, again, the language is end-to-end. So whether you're cleaning and munging data, whether you're doing statistics to it, or whether you're visualizing it, it's all in one shot. And so it makes it really powerful to almost, ask any question, visualize it any way you want, and so on. Any questions?